And we are back. What is up, everyone? Welcome back to the HackMe Twitch channel or to my YouTube channel if you're watching this after the fact. My name is Tyler Ramsbey, and truly thank you for taking a little bit of time out of your day to hang out with me and to learn AWS together. We are going to continue working through the attacking and defending AWS pathway on TryHackMe. It is a business-to-business exclusive, so you don't have access to this with your regular TryHackMe account, but I have access for 1 month, and my goal is to work through the entire pathway covering every module, every detail, so that even if you don't have access, you can still learn from the content. So without any further ado, let's just dive right back into things. I will share my screen. And to show you quickly what we've covered so far, we covered all of introduction to AWS, and we're just about done with IAM. So my goal for today is to finish all of IAM. So I will probably jump off after this lab, at least for those of you on Twitch. On YouTube, I'm sure you can just jump to the next video, and we'll be in the future, and we'll be working through this next one, which will be a lot of fun. This is when we're going to get to some of the labs and attack and defense stuff. So this is our last, I think, real hardcore theory type things, but it is a lab, so we'll see what it's like. And then STS credentials lab. Let's dive into it. Let's get our Cloud Shell open and let's go. Understanding how credentials are generated and can be leveraged is critical for understanding how to attack or defend a cloud account or application. In this room, we will walk through the creation of a new IAM user and an IAM access key for that user. I don't think I have permission to do that. I wonder if I have to regenerate my environment. I'm not sure. We will then use that key to assume a different IAM role to get temporary credentials. You can refer back to the AWS API access key and how services get credential tasks in the IAM credential room. So here is this. We have our IAM user. They're a member of a group which has permissions via IAM policy. They have long-term security credentials used to authenticate to the STS surface, which they can assume a role which returns session credentials. In the above diagram, the IAM group, IAM policy permissions in the role already exist. You will be creating the IAM user and long-term security credentials. From your attack box, okay. We could use the attack box, otherwise we're going to use my virtual box. I'd assume it should work. I have the AWS CLI set up on here, so I'm going to log into Kali, and we'll see if this will be sufficient for us once we get to that point. We'll just minimize this and we'll keep going. In the, let's see. Okay, if you haven't already done so, click the orange Cloud Details button at the top right of the page, generate the cloud environment, and use the creds provided to access your TryHackMe Cloud Sandbox. For this room, make sure to start the attack box and prepare the AWS Cloud Shell in your AWS Sandbox account. We will create a user in the Cloud Shell, then simulate the exfiltrated or on-prem usage of the credentials on your attack box. All right, so in this room, we will learn how to create an IAM user, how to create long-term access keys, how to export long-term access keys as shell environmental variables, how to validate the identity that is currently active, gosh, how to assume a new role using the AWS STS assume role command, and how to export temporary session credentials as shell environmental variables. I've done some of this through CloudGoat, but not all of it. So let's see. I hope I don't have to regenerate my cloud environment for more permissions, simply because it takes quite some time. Not this. VirtualBox sometimes does this things where it perpetually loads, and it drives me absolutely crazy. And the fix is I have to reboot the machine. I don't know if anyone else ever has that problem, but man, it drives me crazy as well. There we go. You can see it's already fixed. I don't know why it does that occasionally. Let's get logged in quick. Okay. We have all that pulled up, and what we could do just to make this a little bit easier, we could just get logged in right here so I can do everything here in my virtual machine. So attacking, defending AWS, we'll just make this full screen, switch. We'll throw it to the side here, and we will dive into our STS credentials lab. And now what I need to do, guys, is I need to stop sharing my screen just momentarily as I log into the cloud environment. So let me do that real quick, and I'll go back to sharing my screen. Username, and I'll grab the password. Whoops. All right. Now I will go back to sharing my screen. There we go. And we are in business right here. So now I'm in my AWS, I'm in my Kali VM doing all of this. My attack box and Cloud Shell are ready to go. They are ready to go. So we will hit complete on that. Accessing the environment. I want to make sure you don't have to regenerate. Okay, hopefully we don't have to. Creating the Padawan user. All right, we will start by creating the IAM User Padawan. IAM users are the easiest way to grant access to a system outside of your cloud environment. Run these commands in your Cloud Shell. We're just going to copy and paste these to see if we run into issues. I think we're going to have a permission issue, but hey, hopefully I'm wrong. So it doesn't say we have to generate this, but I didn't think we were going to have permissions. This would be the confusing part on the TryHackMe side. I don't know how we know when to like generate or how these permissions work. Oh, you guys can see my creds. That's okay. What if I generate environment? This does take a good 5 minutes, so I'm just going to go like this. I think I can. Oh, maybe I can't. I was going to pause the recording for YouTube, but I can't pause it, and I don't feel like editing this video. So if you're watching on YouTube, just like fast forward a minute or so, and it should be generated. For those of you on Twitch, we just get to hang out together, and we can chat. And I suppose we can make our time useful. Let's read about. We're doing STS credentials, so we're studying on access keys and how this can be breached truly is what we're going to do. Create an access key, validate your status. So let's look at oh, hey. Would you look at that? The second link just on Google is from some cool company called Rhino Security Labs. So, hey, we can spend a little bit of time reading through this. One, because it's Rhino, and Rhino's awesome, and it's where I work, and just because it happened to pop up as one of the top links. So, introduction with Paku, and Paku is an AWS pen testing framework. So, think about it like Metasploit for the cloud. Pretty cool tool. I don't know if they'll go through it in this pathway or not. It would be sweet if they did. In our AWS pen testing simulating attacks on cloud architecture, we often get questions about how keys get lost, or even statements that such an event is unlikely. To address these concerns, we've written a blog post to walk through the many ways this could happen. So Git repository misconfigurations. Although it breaks best practice rules, AWS keys are often shared between developers and engineers and companies. And TryHackMe actually talked about this earlier, which means that keys are hosted for us in a shared location on an internal network, such as a private Git repository. This could allow rogue users on the internal network access to AWS where logging cannot necessarily pinpoint the source of the compromise. Another problem can sometimes come in with git ignore files, where developers are expected to house a local environment variable file for secrets such as AWS keys. Sometimes it could be possible for the name of the file to get changed or moved, which would then cause the file to no longer be covered under the git ignore rules. Then without thinking much about it, the developer could actually make a push to a shared repository that includes their personal AWS keys. You could do it on Twitch like me, but thankfully all my Twitch stuff is sandbox account, so it is what it is. The following screenshot shows an environmental variable file on GitHub that was accidentally made public, and you can see the access key and secret access key. Hey, my environment's not ready to use. We'll actually glance through this just so we can get the full view. So we have social engineering, of course, is always an avenue of attack. Here's a fake email. It looks like it was sent to steal AWS credentials. Password reuse, of course, a big thing. And the big thing about cloud security, guys, is it's just regular security applied to the cloud and vulnerabilities in AWS hosted applications. SSRF, that's one thing we talked about on like an EC2 or Lambda function. And you can actually see the SSRF curl request that we talked about before, stealing credentials. Local file read, right through anyway. When you set up an AWS account, it saves it kind of like SSH in an AWS folder, and you can pull credentials that way. Breach and trusted third parties. That would be one way as well. Third-party management, vendor management, internal threat / rogue employees, and of course, that is always an avenue of attack as well. So kudos to Rhino Security Labs. Great blog post. We will dive back into this. I'm going to log out from this environment, and we'll start over with our environment process. Hopefully this works. If not, I'll have to follow up with TryHackMe. I'm going to go back to just sharing my screen, and I will do sign into console. I'm going to pull up cloud details. Okay, so actually I can already, let me share my screen. I can already see that this fixed it. And here's how I know it. If we go to main screen here, just in case anyone watching this has this problem, maybe on the business side, if you look in the environment here, before we had, it showed us a bunch of different environments. This one says STS Credentials Lab. So Amoeba Man, I don't know if you're still on here. My feedback to TryHackMe is when you are changing the cloud environment, make sure you specifically say clearly, for this lab, you need to regenerate the cloud environment, because it just said if you haven't already started the cloud environment, keep going. Well, I already started it, so I didn't know I had to fully regenerate it. So that must be what it is. For this lab, we had to regenerate the environment. All right, let me go back to just sharing my face, and I'll go over to credentials here. And although you guys can't see this, I'm going to type in my credentials, and when I'm done with the credentials, I will go back to sharing my screen, and we will work our way through this lab. Okay, I am logged in. Let me grab my screen, share my screen, and now we can keep moving. So we'll pull up our Cloud Shell here. And I believe this should give us our permissions now. I had my old shell command there, but I'd assume this is a new account. I don't know. Okay, we'll find out. Access in the environment, we did that. So this is where I would suggest it on the access in the environment. Be very specific, saying, hey, this room requires a new cloud environment. Please regenerate your environment. You cannot use the environment you used in the previous room. That's not clear on these instructions, at least to me. All right, creating the Padawan user. Let's try this again. If this doesn't work, I'll follow up with TryHackMe, but hopefully it does. Okay, cool. It worked. Beautiful. So that was the solution. We just had to regenerate our cloud environment. We were able to successfully create our Padawan user. We can see our user ID, our ARN, our create date, and the username. Next, grant that user some permissions by adding them to the Padawans group. All right, and you can see the command AWS IAM add user to group. We're specifying the username and then the group name. We're just throwing them in the Padawans group. Now that you have created the user identity, we will create the access keys for use on your attack box in the next task. Save the output of the create user command so you can validate your identity in a later task. All right. Oh, of the create user. That would be this one right here. So we'll just go ahead and grab this, copy. It wants us to save it, so we'll just open up notes. And there we go. We saved it. And now we're going to do this, which is just going to list the groups for the user, right? All right. What are the first 4 letters of the group ID of the Padawans group? AGPA. Create an access key for Padawan. Now, I've done this in the console a bunch of times for CloudGo. We'll do it via the CLI, it looks like today. Having created the identity and granted permissions by adding the user to the group, you have configured authorization for this user. In this task, we configure the ability to authenticate to the AWS APIs. To use a Padawan user in the attack box, you'll need to generate an access key like so. So AWS IAM create access key, our username, and Padawan. So let's go ahead and do that. Technically, this is going to reveal credentials. But it is just this sandbox environment. So I guess if you guys take the time to access this before I tear down the environment, more power to you. Most of y'all will be watching this after the fact on YouTube, and this will no longer be valid at all. And I do want to show the whole process. So here we go. When you do this, it's going to create our access key ID and our secret access key, and these essentially serve as credentials for the AWS CLI. So now on the attack box, it says we can issue these commands. One way I like to do it, I do it a little bit different, is if we go over to our CLI on here and we do AWS configure profile, and we'll call this Padawan, like that, and then it will actually prompt us for our access key ID and our information there. So for access key ID, we'll grab this right here. Whoops, if I could grab this, copy that, a terminal, paste it in, and then it's going to ask for our secret. We'll grab the secret right there, copy it, paste it in. We'll just say default region, whoops, is US East 2. Okay, and now we have configured it that way. Like right in AWS configure setting, these environment variables tell the AWS CLI. So that's just exporting it. And then I suppose this way you don't actually have to do profile, because the way I'm doing it is I set up a name profile. So now each time I run commands as this user, I have to actually append on the end profile. What is the character length of the secret access key? I believe secret access keys all have the same length, actually. I'm curious if I'm right. Yeah, okay. That's what I thought. They all have the same, which would be 20. Nope. Oh, it's a minimum length of 16. Was it just 16? Nope. Okay. I'll have to stop sharing my screen because the spot where that is at is in my AWS folder. Whoops. Home, Tyler, AWS. It's in my credential folder on here, and because of that, I have to grab it from there. So 1 second, I'm just opening up my credential folder, and then we'll be good to go. I just can't share my credentials on stream because it's going to be everything. Okay, I have it pulled up. Let me clear my screen now, and I'll go back to sharing. Make sure I'm not showing anything. All right, there we go. Beautiful. So I think it's 40. There, yeah, it is. Oh, maybe man even said that, which should be 40. Access key is 20. Then gotcha. Yeah, it was 40. Validate your status on the attack box. The AWS STS get caller identity command is the AWS equivalent of the Unix command who am I? And of course it's way harder, although one fun thing is if you load your keys into Paku and then type who am I in Paku, then it will actually do this as an alias. You should use it regularly to make sure you know which account and user role you're working with. So let's do that. AWS STS get caller identity, but I have to append profile because of the way I set it up. And there we go. You can see that it worked. We're the user Padawan. The user ID you see here should match the one from task 2. Hold on to the account ID returned above. You will need it for the next cast when our Padawan user assumes a new role with more permission. So there is our account ID. I think I have that information saved here. Here's the account ID. Yeah, it's this one right here is the account ID. But we'll just copy this output as well into our notes. Like so. I confirm that I'm using the Padawan user. Confirm. Assume the role of Jedi Master. Now that you've used long-term access keys from an IAM user, we are going to generate short-term keys for an IAM role. In many attack scenarios, you'll be leveraging these short-term credentials, so it's important to understand the basics of these role credentials. The next step is to assume the role of Jedi Master. Looking at this, we already kind of read through this diagram previously, but you can see what we are doing. We're using our long-term security credentials. This is what we just set up. That's how we specify this name profile. We're going to use those to authenticate to the AWS STS service right there. And that the STS service is like the short-term authentication service. And through that, we're going to assume the role of Jedi Master and get temporary security credentials so we can do actions as the Jedi Master. And hey, what up, Oreo Bite? Good to have you here, my friend. To do this, you'll need three things. You'll need permission to assume the Jedi role. This is provided by the policy attached to the Padawan's IAM group. Refer to task 2 where we added the user to the Padawan's IAM group. The Amazon resource group name of the role you want to assume, this will be this one right here. So let's grab this and let's drop it into our notes. Our account ID is right here. And we'll replace that. So that's our role. In a role session name, this string will appear in CloudTrail logs and help administrators distinguish who or why a specific role was assumed. For this, we shall use the name of someone who almost became a Jedi Master. Okay. So this is the command. I want to just look at this command ourselves, see if we can break it down. So we have AWS STS assume role. Okay, we are familiar with that command. We're passing it the role ARN, which is this one right here. And we're giving it a role session, and this is what's going to appear in the logs. And what I have to do is append this with profile Padawan. Okay. There we go. So once again, generally you don't want to share these credentials, but because it's a sandbox and if you want to log into it, be my guest. I'll shut it down. Maybe I said I think Anakin is a more fitting name here. Yeah, I think you're right. I don't even know who Ahsoka is, but I'm also not a big like Star Wars person. I'm big in Harry Potter, so I understood the Harry Potter references before. Now take the output of the assume role command and set the 3 AWS CLI variables required to use temporary credentials for the role rather than the user. And the way I'm going to do this is I think I will set up another name profile because the benefit of doing the name profile is then you can switch between different users just by doing the profile name. And so that's how I'm going to do it. But in order for me to do that, I once again have to stop sharing my screen because it's going to show my credential folder. Give me just a moment. I have to type all this information in. I'm calling it fake Jedi. So I don't have to type that other name each time because I'm going to definitely spell that other name wrong. And I'm going to pull the access key ID. Now to do this, you actually, if you're doing it like I am with the name profile, you actually have to add this to your credential file because when you set up the name profile via the CLI, it does not prompt for the session token. So I'm actually editing that with Nano and adding these correct things in there. So then we can make, from our name profile, we can do it as our fake Jedi profile. Okay. Done. Share my screen. Keep going. How many minutes are your session credentials good for? What's the hint? Oh, we can do it in cloud. Well, yeah, I guess I'm not sure the time zone and things, but we'll just try to do like the who am I command, which is the STS blah, 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 blah. So even though I've done it this many times, I still don't have the command memorized just because it's not simple because it's AWS. There we go. STS get caller identity. Oh, it was like right in the previous task. So if we do AWS STS get caller identity profile fake Jedi. There we go. So we are logged in as the Jedi, though it doesn't give us the time. Do I need to do a specific call? Oh, would it say it? It would have said it when I did the initial call, which I already removed. It told me the expiration. Shoot. Well, let's just do the call again, I guess. If I go back to this command, did not mean to do that. Can I just do it again? There we go. So here is the expiration. 4:07. How many minutes is it good for? It says, how can we know the current time in the cloud stuff? If we go to the cloud CLI and type date. Okay, so here's the current time, 15:08, and if we go to our CLI, these are good till 16:07. So 15:07 to 16:07, so an hour, I would think, 60 minutes. Yep. Wasn't very good at math, but I at least got that math down. How many AWS CLI environmental variables were required to be set? 3. Secret access key ID, and session token. Validate your newly found powers, which we already did, but we'll do that again. Here's our fake Jedi profile. Now that you configured the AWS CLI environment with your new credentials, verify you're acting as the Jedi role. And we did. You can see we are role, Jedi, and Ahsoka. The Star Wars fans are going to murder me for saying that name terribly wrong, but this was a reasonably simple exercise. However, the things we've done here are fundamental for understanding the credential exfiltration techniques we will do in later rooms. As a defender, it's very important to be able to recognize credential strings when you see them in source code or bug bounty reports. Best practice is to avoid the use of long-term credentials. Because even if you steal my session credentials I showed on stream, you can only use them for an hour. Actually, I'm going to regenerate this environment as soon as I'm done, so you can only use them now for like a minute or so longer. But even if they did leak, they'd only be active for that hour. What IAM resource does a string that begins with AROA represent? I don't know. IAM role. Roll. Boom. We have finished the STS credentials labs, which if we go back to our learning path in what I started this, did I start this 2 days ago? In 2 days, guys, I've grinded it out. I'm 40% done with the pathway. I finished all of Introduction to AWS, all of Introduction to IAM. And in the next stream, that's when we're going to get into some fun. We're doing the attacking and defending core services, attacking and defending serverless, and IAM privilege escalation. So we're going to dive into the more hands-on AWS pen testing in the next stream. But for this one, I'm going to call it a day, at least on the streaming side of things, but I do have to work the rest of the day. But guys, thank you for hanging out. Do appreciate you taking the time here. If you're watching on YouTube, hopefully by the time you watch this video, there's another video right after this that you can jump into. For those of you on stream, I usually stream at night. I will not be on tonight because I'm taking my kids to a fireworks show. The fireworks show that was originally for the 4th of July got postponed due to weather, so it's supposed to happen tonight. So I will not be around this evening, but I'll be on, honestly, most nights working my way through this pathway. So thank you guys for hanging out, and I will catch you guys in the next stream. See ya.